Hi everyone. Now we will discuss the question number 15. A flat surface of a thin uniform disk A of radius R is glued to the horizontal table. Another thin uniform disk B of mass M and with the same radius R rolls without slipping on the circumference of A as shown in figure. A flat surface of B also lies on the plane of the table. The center of the mass of B has a fixed angular speed omega about the vertical axis passing through the center of A. The angular momentum of B is nm omega r square with respect to the center of A. Which of the following is the value of n? Observe this carefully. There is a flat surface of thin disk A. This is fixed at this point, and the second disk is rotating with angular velocity omega, and this disk is you can see it is rolls without slipping. This is rolling without slipping, rolling without slipping. Just observe that I am writing these diagrams below this. Now there is a fixed disk, a disk which is fixed, and there is one more disk having same radius. This radius is r, this radius is also r. Okay, now we can see this is moving, this is rolling without slipping, fixed, and it is at rest. A is at rest. Okay, now if it is rotating with B, we can see the B will rotate like this. It is going like this. Now if we see at a particular location how the B is there, B will be like this. Now you can see center of the B is like this, and it will have velocity like this. At the same time it is also rotating. Let us consider angular velocity of the B is omega naught. It is also rotating about this. Okay, it is rolling without slipping. Now if we see at any point the center of the B is moving with the speed of velocity of the center of mass of the B can be written as the total radius of this circular orbit is, you can see total radius of the circular orbit is 2r. At any point it will have velocity of center of mass of the B is equal to 2r into omega. So here also we can write 2r into omega. Observe this, 2r into omega. At the same time it is also rotating. So if you see at the bottommost point, it will have like a r into omega naught. At this point we can see velocity of center of mass. Okay, as disk A is at rest. Okay, and there is no slipping. Of disk B. You can write it as velocity of center of mass of the disk B is equal to r into omega naught. This value you can write 2r into omega value is equal to r into omega naught. Finally you will get the angular velocity of the disk B about its center is 2 times the omega. This is 2 times the omega. Okay, now we can see disk B is moving. Disk B is moving with velocity v is equal to 2r omega. At the same time the same disk is rotating about its center, having angular velocity is omega naught. Now we can write angular momentum of disk B. Angular momentum of disk B about center of disc A. It is rotating as well as translating. You can say about the center A center. It is rotating as well as means it is revolving as well as rotating about it one axis. Okay. Now it is revolving around the A as well as it is rotating about one axis. Now you can add angular momentum of the B about A can be written as angular momentum of the B about its center of mass plus angular momentum, this mass into velocity of center of mass r bar cross. So you can write 2 into r into velocity of center of mass. So this is moving, this is also moving in same anti-clockwise direction. You take the whole values are same direction only, it will be added. Let us consider that value is k cap. You this I into omega m into r square by 2 into omega naught into k cap plus you can write 2r into m into velocity of center of mass is equal to, we can write as 2r into omega into k cap. As a whole, you can see that m into r square by 2 into omega plus 4 into mr square into omega whole thing into k cap. 2 and 2 get cancelled. As a whole, you can get 5 into mr square omega into k cap. So they are asking that what is the angular momentum of the B with respect to the center of the A. Nm omega r square is there. So n value is equal to 5.